students, I am Dr. Nimi Singh. Today I bring you a learning module in BSc Forensic Science on behalf of the content writers Dr. GSOD and Miss Tulika Banerjee on a very important unit of Forensic Ballistics, which is Examination of Firearm Part 2, in which we will discuss about accidental discharge, identification of caliber from projectile entry hole, ricochet analysis, bullet penetration and trajectory of bullet through glass. In addition to it, you will also be told about the improvised and country-made firearms, along with their examination and nature and identification of firearm injuries. We will wind up this module with a discussion on reconstruction of crime scene with respect to accident, suicide, murder and self-defense. Dear students, recall that in the last module, which is examination of firearm part 1, we studied about history of forensic identification system, rifling types and their identification, types of chambers, basic methodology used in comparison microscope, and also discussed about the mathematical proof in striation matching. Let us start our module with a look at what we are going to learn today. Causes of accidental discharge of firearms, identification of caliber from the bullet entry hole, ricochet, analysis of ricochet, bullet penetration and trajectory through glass, improvised and country-made firearms, the nature and identification of firearm injuries, reconstruction with respect to accident, suicides, murder and self-defense, and then a conclusion of all these topics in the end. Let us come to the introduction first. Now, crimes related to firearm are of 3 types: homicidal, suicidal and accidental. Firearm usage in homicidal and suicidal act shows malignancy and intention on the part of the firearm user, but in the accidental type crimes, it is nearly impossible to give inference on any intention. Now, there can be several reasons for accidental firing which may not be calculated single-handedly. However, some reasons have been identified as a part of the firearm defect and have been discussed in this module. Now, according to a survey in India, the cases of death due to accidental firing are very common because of easy availability of improvised firearms. It often comes across in the news about deaths due to accidental firing in wedding ceremonies and other similar functions. Moreover, lack of proper knowledge of handling weapons is also a common reason for accidental cases related to firearms. Let us now come to the causes of accidental discharge of firearms. The materials are not always of the best quality. It is not unusual for there to be sufficient play in the mechanism for the firing pin to touch the primer. Now, dropping the weapon inadvertently, striking the hammer will often accidentally discharge such a weapon when it is in the half-cocked safety position. As discussed earlier, there may be several reasons for accidental firing cases, but to conclude the fault in a broader way, some causes of concern have to be discussed below. Mishandling of firearms. Now, it has been often seen that firearms possessed by the user is not used or kept properly. It has been frequently observed that the user, with lack of knowledge of handling the sophisticated instrument like firearm, may cause unintentional damage to it by leaving it unattended or improperly attended. Now, manipulation in the internal mechanism of firearm. Now, some users are so eager to experiment with the weapons in their possession that they manipulate the mechanism of firearm according to their own preferences. Most commonly, the barrels are shortened or the trigger pull is lowered, or even sometimes unnecessary greasing is done to provide smooth mobility of the bullet. All of these efforts make the weapon prone to accidental damage. Especially in the case of shotguns, where the barrel is shortened off and gunpowder cartridges are used in place of smokeless powder cartridges. There is a strong possibility of bursting of cartridges due to excessive release of gases. Now, inadvertent trigger pull. Generally, this is very difficult but not impossible to prove one way or the other, whether it is inadvertent or otherwise. Now, numerous cases are on record of a violent fight during which a person holding the weapon has been violently thrown back against a wall with a claim inadvertent discharge of the weapon. An excellent piece of work has been done by Brian J. Hurt, which has been unpublished, using volunteer under controlled conditions to test the probability of inadvertent trigger pull. It has been found that for self-loading pistols and revolvers in the single action mode, there is a little tendency for the trigger to be pulled if the person holding the weapon normally releases the trigger. Now, for revolvers in the double action mode, it has been found that there is no tendency at all for the trigger to be pulled. It is worth noting that those conditions under controlled test and those when there is a violent confrontation or when person fears for his life are completely different. Less trigger pull. Now, although the accepted trigger pull of commercial and military firearms varies tremendously, but the following are considered as acceptable. 0.22 inch rimfire rifles 3 to 5 lb, military rifles 4 to 7 lb, revolvers single action 4 to 6 lb, revolvers double action 10 to 15 lb, self-loading pistols 4 to 8 lb, shotguns 4 to 5 lb. Now, most frequently it is observed that a person acquainted to a particular kind of weapon and used to pull the trigger very hard accidentally pulls the trigger of a different weapon which may have less trigger pull, causing accidental discharge. Faulty ammunition. Now, defective ammunitions may also cause accidental discharge of the firearm. Improper mixture of the propellant or wet mixture may cause slow ignition of the propellant, which can cause irregular release of gases and may also cause explosion. It has been observed that to ensure more lethality, the bullet core or the pellets are distorted, which can cause damage to the barrel, resulting bursting of the barrel. Faulty safety mechanism. Now, due to improper handling or manipulation, or sometimes due to manufacturer's fault, the safety mechanism of the firearm gets malfunctioned. This malfunctioning is, however, very dangerous and can cause accidental discharge even when the safety switch is turned on. Environmental factors. Now, besides human interventions and manufacturing faults, the environmental factors are also responsible for the accidental discharge of firearms. Blockage of the barrel or the chamber with mud, soil, water or other extraneous materials may cause bursting of barrel. Deposition of rust in the firing mechanism is also a cause of concern. There are numerous recorded cases of twigs snagging on the trigger of loaded shotguns and rifles. Identification of caliber from the bullet entry hole. In skin and fabrics, unless a wad cutter type bullet is used, it is impossible to determine the caliber of a missile from its entry or exit hole. Wad cutter bullets are intended for such target practice. As such, they are designed to cut a clean hole through the target to facilitate the determination of the shooter's accuracy. Round-nosed or even hollow point bullets are used. The hole produced by the bullet is very much smaller than its caliber. In skin, this is caused by its natural elasticity, which allows the bullet to force apart the cell structure. After the bullet has passed, the skin regains its original shape, exhibiting only a very small entry hole surrounded by a bullet wipe mark much smaller than the original caliber of the bullet. In fabrics, it is the weave which separates, allowing the bullet to pass. Often, torn fibers will be visible, but these indicate little other than the direction in which the bullet was travelling. With wood, the bullet entry hole is once again much smaller than the diameter of the bullet. The wood fibers stretch and eventually tear as the bullet passes through, and most of them spring back, making it extremely difficult to determine the caliber. When dealing with wood, there is, however, a little known method of determining the caliber with a reasonable degree of accuracy. If a piece of fairly strong white paper is placed over the wood surrounding the hole and a soft lead pencil is carefully rubbed over the surface, as in brass rubbing, a circle, a very closely approximating the diameter of the bullet will appear. The determination of caliber from a bullet hole in a vehicle body can also be extremely difficult. For example, semi-jacketed hollow point bullets can expand on impact, giving the impression of a much larger caliber. At other times, the jacket material can be stripped off, leaving the lead core to penetrate, giving the impression of a much smaller caliber. Conversely, extremely high velocity bullets can leave an extremely large entry hole. Often there will be a splashback effect where metal flows back out of the hole, giving the impression it is an exit and not an entry hole. Identification of just the entry or exit holes in these circumstances may require considerable experience. Determination of bullet type. As the bullet passes down the barrel, the rifling will tear off small fragments of the bullet. Some of these fragments will remain in the bore and others will be blown out of the bore by the gases following the bullet. Some of these fragments do, however, remain attached to the bullet in the form of submicroscopic pieces of swath. As the bullet passes through any material, whether it is human flesh or fabric or wood, these fragments are often transferred to the medium through which it is passing. These fragments are exceedingly small, but if an adhesive taping is taken from the periphery of the bullet entrance hole, they can be recovered. Examination under the electron microscope will enable these fragments to be qualitatively analyzed and the bullet type and or country of the origin to be identified. It is important in the interpretation of these results to distinguish between volatilized lead from the bullet base and lead fragments from the bullet driving surface. Volatilized lead will be spheroidal or having smooth contours, whilst lead from the bullet's surface will be more rough and swath-like. The importance here is that as the metallic components of the lead alloy volatilize at different rates, the results from the volatilized lead will be different from those torn off the driving surface. Likewise, it is important to distinguish between copper zinc alloys from contamination and those particles torn from the bullet's jacket by rifling size, and morphology is one identifier, the other is from the quantitative analysis if this is possible. Ricochet. Ricochet phenomena refers to the deflection of projectile from its trajectory or line of motion after hitting a hard object, even from bones. Whenever a bullet is fired on a target, it will either penetrate or bounce off and continue to move at a certain angle, and when it bounces, it produces the following effects. The trajectory of the bullet effectively gets changed. Apart from the fact of changing direction of motion of the projectile, the angle of deflection also undergoes a substantial change. After ricochet, the projectile tends to lose considerable amount of its energy, which may be anything up to 1/3 of its total energy. It loses gyroscopic stability and may tumble after ricocheting. The range will decrease, which is in contrary to the popular belief that a ricocheting bullet will have the elevation for maximum range. The projectile may carry some material from the surface of the target after ricochet. Critical angle and ricochet angle. The actual degree at a bullet producing ricochet from a surface is called the ricochet angle, and the minimum angle at which the bullet may produce ricochet phenomena is known as the critical angle. Prediction of the critical angle for any bullet. Surface configuration is, however, extremely difficult. Factors such as the bullet shape, construction velocity and ricocheting surface all have a pronounced effect on the outcome. In the above figure, angle A refers to the angle of incidence and B refers to the angle of deflection. On an ordinary ground, the bullet will generally penetrate if it strikes and at an angle greater than 15 degrees. But there is nothing certain about this. The tendency to ricochet is very much affected by the shape of the tip of the bullet. A round pointed bullet will tend to ricochet easily than other shapes. Analysis of ricochet. Affecting parameters. The potential to ricochet is so diverse that it is nearly impossible to lay down any firm and fast rules. However, there are a few generalizations which may be applied. Anyhow, the ricochet of bullet strictly depends upon the state of the target object. The evenness of the surface also plays an important role in ricocheting of bullet. In most of the cases, the angle of ricochet is considerably less than the angle of incidence, but it is not so in all the cases, especially with hard projectiles, that is jacketed bullets, high velocity projectiles penetrating a frangible material such as stone or concrete. The critical angle for a soft or hollow point bullet is slightly lower. For an equivalent fully jacketed bullet, it would appear that the collapsing hollow point nose increases the incident angle, thus increasing the propensity for ricochet. The critical angle for a given bullet type or target medium is not velocity dependent. Bullet will invariably lose its gyroscopic stability and tumble after ricocheting. The tumbling gives rise to a distinctive whining or whirring noise as the tumbling bullet passes through the air. Bullets which have ricocheted from glass, steel, concrete or wood have a very distinctive material where the contact has been made. The contact point will often have wood, fiber or concrete adhering to it. For easy identification, if the material was glass or polished steel, the mirror-like surface is quite distinctive. This is not, however, the case with a bullet which has ricocheted from water. Even with hollow point bullets, it is differentiated between a bullet which has ricocheted from water and one which has not. Wounds and ricocheting. Now, wounds produced by bullets ricocheting from hard surfaces can be easily identified. The entry hole caused by a bullet after ricocheting will be very distinctive, as it is caused by a distorted bullet which will generally have ragged edges. After it enters the body, the bullet, due to its inherent unstable condition, tumble over and would leave a large and irregular channel. Jacketed bullets tend to break up on ricocheting, and possibility of recovery of fragmented jacket and let go are more. High speed bullet with a thin jacket, for example 0.223 inches or 0.22 inches swift, will invariably break up before ricocheting. Fatal wounds and ricocheting. Ricocheting of bullets cause serious injuries and even fatal ones. It is well established that after ricochet, the bullet substantially gets deformed, as in case of lead, or gets fragmented, as in case of bullet jacket. The ragged shape of bullet is then capable enough to produce devastating effect, and the entry wound may be fatal. Billiard ball phenomena and dum-dum bullets are good examples for producing fatal injury. Now this is the time for your self-study. If you want to learn more for enhancing your knowledge, you may log on to our website www.cec.nic.in for assignment MCQs, quizzes, LORs and other materials. Till then, keep studying. Goodbye.